subject of interest in evolution is speciation. So what we've talked about so far is just microevolutionary processes that happen in a particular population, and that population may change to suit its environment. But what we really want to know about too, or what we also want to know about, is speciation. That is, how do we develop a new species from species that exist? Because as we saw on the evidences of evolution, that species, there are a lot more species than there used to be. So somehow there is a process that is creating new species. So let's hypothetically think about the eastern seaboard of the United States. This is supposed to be Florida. This is the Appalachian Mountains, and this is up in Maine and so forth. All right, so what I've tried to depict here is, let's say, for example, we have like a group of organisms that exists all the way north to south. I believe there's a salamander, it's called the red-eared salamander. I'm not sure if I'm absolutely correct on the species, but it existed all in the, whatever it was, it existed all the way from the north to the south. And it's very sensitive to, it needs damp environments to lay their eggs and to actually have reproductive process. So it's found, you know, in riverine areas. And what happened was that the acid rain that's come from the industrialization of the northeastern United States has caused places in the Appalachian Mountains that normally would have the red-eared salamander to not have them. So basically what happened was they got eliminated from that portion of the environment. So what that created was an isolation of the northern and the southern groups. So if you can imagine, let's say, for example, and I'm being totally hypothetical here, not particularly talking about this species, but let's say, for example, the ones in the south, they might have a mating time, let's say, for example, in May. And that's fairly early, whereas the ones in Maine or up in the northeast, their mating times may be like late June. So their mating times would be completely different, and the ones in the south may in fact have two mating times, or their mating times, and they have they have like a late summer one, whereas the ones in the north would then just be completely off, being mating in late June. They would only have one mating time. So imagine then putting these two species together. That is, they would no longer be able to mate because their mating times would be completely different. So in essence, through this reproductive isolation, they have become species that do not interbreed. So I back up a minute. Let's just say, what is a species versus just a population? A species is a group of interbreeding organisms, and a population is a group of interbreeding organisms in one location. So a population is a subset. So the ones in the south would be like a population, the ones in the north would be another population. They would have had evolutionary change, and now they have become perhaps new species, that is non-interbreeding groups. All right. So there's basically two types of speciation. So I just described one, which is allopatric speciation. This is with geographic isolation. And there's other examples of this. They have one in your book of fish that got separated in different ponds. African cichlids are another example. African cichlids exist in the rift lakes of Africa, and the lakes have many different conditions. They used to be all sort of together, and then as those mountains uplifted and created these many different lake situations, they were then under really different conditions. All right. Then, so they have different features and so forth. Sympatric is where you don't have geographic isolation. So this would be groups that are closely related, that are creating hybrids. Now, in animals, this doesn't often create a viable offspring. In other words, like the liger and like mules, cross between a horse and a donkey. These hybrids, although they in themselves are good individuals, they cannot interbreed. So that is not sympatric speciation. What you have to have is an interbreeding group. So an example of one that can do this is wheat, where they do trisomy, which is the non-disjunction. They create a situation where they have 3 of each homologous set, and if you have that happening in more than several individuals, then you can have cross-fertilization and you can create a new species. So this happens in plants a little bit more often than it does in animals, although there's examples in animals as well. Okay. All right, so once you create a species, how do you maintain their genetic isolation? Because that's what we're really talking about here, is that they can't interbreed with other groups. So there's what we call pre-zygotic and post-zygotic mechanisms for maintaining genetic isolation. So pre-zygotic things are just like what we've been talking about, geographic isolation, but they can also include things like temporal, which was, like I was saying, the mating times were different, the nesting times are different, that kind of thing. It can be visual cues, things like fireflies, for example. The different species may flash differently or have a different color to their flash. And in fact, that is actually true of lightning bugs, or some people call them lightning bugs, in the Carolinas. Pheromones are another example, that pheromones are attractive usually to mates of the same species. If you've ever had a dog that is in heat, you know what I'm talking about, because it's attracting all the dogs in the neighborhood. So pheromones are a way to draw the mates in, or to indicate mating time is now. And then there's mating rituals, rituals that you have to go through in order to mate. Really a famous example that's studied a lot is sticklebacks. Sticklebacks have one set that swim in a certain direction, and then another species of them swims in the other direction. And if you happen to be the one that swims the wrong direction, you don't actually get to mate. All right, the post-zygotic things are things that happen with the actual reproductive process, like that the things don't fit together, so the zygote doesn't form, or the zygote isn't viable, or the offspring isn't viable, and or reproductive, those kinds of things. It's mostly about things that are about mating. All right. Now, one of the things about this allopatric speciation, what they're talking about here is that if I had, for example, this is what they call adaptive radiation. If I had a population, let's say population A, that was moving to an island community, maybe they got blown there, let's say a bird population or something like that, and they get blown in, and then what happens is, so they're basically like that original population. But then what can happen is they can get moved or blown to a neighboring island, and perhaps there might have been some kind of evolutionary change before that happened. So really in this depiction, they're thinking Galapagos here, right? That you had the finches, they got blown to the islands, the resources were different. So there was possibly a slight evolutionary change in their beaks for using the food sources that were available. Then that group gets blown to the next neighboring island. They also have some kind of evolutionary change. Again, maybe another change in their beaks. And they may in fact go back to the original island or to another island and change again. And so you may end up having several different species that are on these islands, and that the way that it happened was through what they call this adaptive radiation, that there were changes, each with geographic isolation initially, and then there is a mix later on where they are maintaining their maintaining their reproductive isolation through probably one of these pre-zygotic mechanisms. All right, so there's that. Then there's another idea. This is what they call a cline, where you have different, basically a species that is similar, or it starts off the same, but it occurs in different places and in a particular really different environments. So in this case, it's going up a mountain where it's colder, drier, etc. And what happens is there's differences in the plants, and then that may create, again, differences, you know, like what we were talking about before, differences in, say, reproductive times and or the mating mechanisms that occur that would then keep this species and this species from being from interbreeding. All right.